As a young woman at 12 years old, I saw an image that is very similar of this galaxy over here, about the Andromeda Galaxy. That is the closest galaxy to our Milky Way. And what I noticed there very early on, at that young age of 12, is that it was 2.5 billion light years away from Earth. Light years? What are they talking about? To me, light is that, and years is time. How is something 2.5 billion light years away from where we are today? I started learning more about space and what it was all about. And I came slowly to the realization that this wide expanse of galaxies, of stars, of black holes, of rocks and ice, and different objects and planets that were within those galaxies, and within several galaxies that made up parts of the universe, was mathematical equation, scientific theories, physics. People here on Earth have been studying it for centuries, and they've gotten to a point where they put it down in a very nice and quaint way. Not easy, but a nice and quaint way to start explaining where it started from, how it's currently developing, the sort of rules and frameworks that govern this vastness that our human brain is somewhat comprehending. I really wanted to go and study that science. But as I soon came to the realization, space science, that form of physics, that form of creation and finding new fundamental understanding in this field, was something that was for a few nations. It was segregated towards a small portion of Earth. A small portion of people could actually go into it. At that time, in the UAE, we did not have a space sector. I did not settle. I went to my second passion, programming. I loved creating things on computers. So I pursued a degree to become a computer engineer. Unbeknownst to me, in 2006, the UAE started the first buds of its space program. That started about 10 years from today, and they started in those developments of developing satellites for the UAE. I did not know it in 2006. I joined the team 3 years later, in 2009. They were still at the startup phase, and I joined it completely by chance. I didn't know they existed at that time. Probably I did not have time to read newspapers, but still, I did not know that they existed at the time. I joined them early on in 2009. And what I realized during that very first week, and they had told me beforehand before joining that they're working in the space sector, so I'm like, check. I had a dream at some point in my life to work in space. So sure, I'll join you guys. They've already developed one satellite, and they're working on developing a second satellite, and I'll be part of that team. The team was made up, was about in their mid-20s. They started working in their early 20s when they had just graduated and gotten their degrees. That was the whole team that was working. All the engineers were within that demographic. And they were working on developing a satellite. Some of them were based here in Dubai. The others were based in Korea. But what was surprising to me, and at that point I actually paused and thought twice about what I'm doing, was the job that I came into was created for me, and that's how jobs happened. We were new and starting, and that's how we started expanding. Whenever they found the right person, they linked him to the right job that should have been there but did not exist before that. So I had nobody to learn from. My entire perception of what a workplace should be, that I should be mentored in some way, that I should have a reference point of somebody to actually work with, shattered that day. The only thing that they had provided to anyone joining there was a goal that they needed to achieve that was part of a project that needed to be developed, and the results of it needed to be produced at a certain point in time. So I did not have time to explore and sort of learn along in my own jolly time. So it was a constrained time. And there was a team leader that provided each team member with the sorts of resources and tools that they required to develop that field. But it was the responsibility of myself and each and every single person within that team to develop that entire area within the organization and eventually grow people within the organization in that area. That first week was quite surprising for me, and I paused there for a moment and said, shall I go forward with this to what to me was something completely different than what I had realized? For what was at that time a really large challenge for someone who was 21 to overcome. I chose to take that challenge, and I chose to try it, and that has been my motto across life. I have never said no to an opportunity that has crossed my path without even trying it, because to me, there's absolutely no problem with failure, because I learn from that. So I always go down paths, even if I am unsure that I can achieve them at any given point in time. Fast forward about 5 years from there. It was November 21st, 2013. We had already one satellite in orbit that was taking images of Dubai and the UAE and was actually helping in development projects across the UAE. It was the day of the launch of our second satellite. And we had the third satellite in development that will be developed and is currently being developed right here in Dubai. That day for me was a turning point. I had achieved what I wanted to achieve in space, but I wanted to expand further than that. I wanted to expand further into science and technology and different fields in science and technology. And I was thinking of going towards an opportunity of working within the organization on an unmanned aerial vehicle or a UAV program. But also on that day, that was the first day, that I heard that the UAE was considering a Mars project, a planetary exploration project. Everything came rushing back. 2.5 billion Andromeda, exploring planets. That's what I wanted to do at some point in my life. And we were asked a few strategic questions from key stakeholders in the country. The UAE, you see, wanted to celebrate its 50th anniversary with a contribution to humanity and a contribution to science. They needed a spacecraft to be developed to go to another planet, Mars, because Mars is of interest to humanity today. To gather data that scientists don't have access to today, and to answer novel questions that have been posed about Mars, but we currently don't have the necessary information to start answering those. And we needed to do it before 2nd of December 2021 so that we can mark our 50th anniversary with that achievement. We started a feasibility study on that day that lasted a few months. About 4 of those people, including the project manager, were part of those, and some of them are the deputy project manager of the project, are part of that first team that actually worked on this project. And we had about 100 days to come up with the science of the mission. I'd like to take you a step back. Usually, planetary exploration missions take about 10 years in development. They start with the first phase of defining the science. So you're sending an orbiter or a lander or a rover to another planet. What is it going to do? That's where scientists come into play. And then you start building up the spacecraft from there. So you start from science and you start building up to see what you need in terms of technology, what you need in terms of instruments and a spacecraft to achieve your science goals. That process of getting the science questions and nailing down exactly what you're going to do and what kinds of instruments are going to capture your data takes about a year. Because we had 6 years only for development and not the standard 10 years, we calculated that we had approximately 100 days to define the mission, to select the science questions, that scientists are posing, and there are absolutely no other missions that are being sent there until 2021 that would provide data for that. We quickly put together a team of scientists representing different sciences in Mars and different areas in Mars, and started going through all the possibilities of what the spacecraft is going to do. Those the initial 2 months to me and the rest of the team who's working initially were very long days and even longer nights. You see, we all had our day jobs, and I'll get you back to the day jobs, but we all had nighttime meetings to fit in with the different international scientists that we're talking to and discussing the possibilities of our Mars mission. Most people here were having dinner with their families, dinner with their friends, TV dinners. I was having dinner in front of a laptop with discussions of science, talking about a field that I had just come into, which is the latest discoveries about Mars science and planetary exploration. I remember one day quite clearly. It was a day where a meeting started at about 6 or 7 p.m. That meeting was meant to run up to 3 a.m. So I stayed in that meeting till about 10. We were discussing several options of the spacecraft configuration, several options of what the science and the instruments could do. And on that day, I also had the launch of our first high-altitude pseudo-satellite that we were developing as a team. A pseudo-satellite, or HAPS, is a UAV that flies to about 65,000 feet. That's about 20 kilometers. So it flies in the stratosphere. Our normal aircrafts fly at 12 kilometers, about 40,000 feet. So to give you that sort of difference in height. I stayed there with the team till about 10 or 11 p.m. Said goodbye because I needed to check home and sort of tell my family, hey, I still exist. And then drove to the site that we had here in Dubai in the middle of the desert at about 2 a.m. because we needed to prepare for a dawn flight. And the team did a great job in preparing that dawn flight. And we managed to fly an experimental UAV to the highest altitude of any aircraft, which is above of 65,000 feet over the airspace of the UAE, next to the world's busiest airspace without disrupting Dubai Airport. That was a feat by itself. That was an exhausting day. But about 1:30 p.m., when we reached the stratosphere, I saw something that reminded me exactly why we're doing this. Why are we working on defining this mission? And I saw the edge of space. I saw the horizon, the Dubai waterline, and I also saw the edge of space, the darkening of the sky that starts happening in the stratosphere. And to me, it made all the hard work that went into defining this mission, the Emirates Mars Mission, the Hope mission, well worth it. At the end of those 100 days, we were able to come up with the science of the mission. So what is the mission going to do? The mission is going to provide scientists with the first holistic view of the Martian atmosphere. We're going for the first time to understand the climate of Mars over an entire Martian year, the entire climate of the planet. A lot of people ask me that there has been other spacecrafts that have gone to Mars. We know what the average temperature is on Mars. We know what the lowest temperature is on Mars and what the highest temperatures are on Mars. We also know that there are dust storms and different features and clouds that are there. Why is your mission novel and why is your mission new? Well, the current data that we have on Mars is using 2 different times of Mars days and covering just specific areas of Mars. So it's as if I'm coming to tell you to come and study Earth. Take the temperatures at 2 p.m. and 2 a.m. every once in a while. Take it over Alaska, and come here and take it over Dubai. And please summarize what is the climate of Earth. That doesn't really give you a proper reference point. So that is the answer that we're giving. But most importantly, we're trying to provide a sort of piece, a missing piece of the puzzle of our understanding of what happened and what is currently happening to hydrogen and oxygen atoms on Mars. Hydrogen and oxygen, why are they so important? Because they're the building blocks of water. Water existed on Mars' surface. Flowing water existed on Mars' surface at some point in time. There were changes that occurred to this planet, some of them climate changes. And hydrogen and oxygen today are escaping from its atmosphere. We want to understand, is Mars' climate, is it playing a role in the escape of hydrogen and oxygen? Water, again, is important to us in planets because Mars exists in the Goldilocks zone. And water, as we understand life, is one of the building blocks of life. And it's called hope for a reason above and beyond the science that it's contributing. Today, our region, the Middle East, is filled with turmoil. It is a region that is going through a few of its darkest hours. And what we are doing at the Hope Emirates Mars Mission is providing a message. The Middle East is made up of over 50% youth. This project, Hope is being run by a team that is under 35, a team that is made up of 34% women. The average age is 27. An entire nation is putting its hope in a team of youth and presenting a message to the region. This mission is also called Hope because we are contributing to the global understanding of a planet. Data, we are going above and beyond the turmoil that is now defining our region and becoming positive contributors to science. Science, to me, is the most international form of collaboration. It is limitless, it is borderless, and it's run by passions of individuals for the benefit of human understanding. Today, I'd like you all to do something with me. I want everybody to lift up their finger and cover a region of the sky. Look up at your finger and sort of the region of your fingertip that's blocking the sky. The Hubble Space Telescope was pointed at a region that small, and it came up with this image. This image, the dots of light that you see in these images, are not stars. They're galaxies. There are hundreds of billions of stars, each one of those dots, in that small region of sky that we look at. Each hundreds of billions of galaxies contains billions of stars. Each star, imagine how many Goldilocks zones exist around them. How many planets could possibly exist around those? And how many possibilities of life that there could possibly exist in this small portion of the sky. And today, I'd like you all to imagine what is the positive contribution that you're doing right here on this unremarkable planet, in this unremarkable solar system, in this unremarkable galaxy, that justifies how infinite the possibilities are in this small image, and how positive and infinite your contribution is on this infinitesimal planet. Thank you.